The world's largest machine. The North American power grid supplies over 4 trillion kilowatt hours of electricity to homes and businesses over a massive area. Much of this machine relies on availability, reliability, and durability of wood power poles. But the wood poles have a sinister foe: wildfires. Quantum Chemical has been helping utility companies battle this foe for over 25 years.
Our previous solution was a two-coat system using an intumescent coating and a protective top coat. An intumescent coating reacts to the heat of a fire and swells to create an insulating char layer to protect the substrate. The protective top coat provided longevity to the water-sensitive compounds that produce the intumescent char. Our goal for Safecoat PFP was to develop a weather-resistant intumescent coating that would not require a top coat. This simplifies the application process while maintaining longevity.
Our initial work focused on the development of an intumescent coating with excellent weather resistance.
These two samples came out of the testing that we did using 1 week of prehesion testing and 1 week of UVA humidity testing, and then we cycle it for 2 weeks before we start burning the samples.
We screened those formulations using the 2-foot tunnel tester. We then needed to determine what's the model we're going to follow to predict large-scale performance in the field. We needed to develop a test standard that we could follow that would give us good predictability.
And these two here are our standard intumescent coating for indoor. And so these 4 here are different trials. For outdoor exposure, we change some materials, and you will see it has better intumescence compared to one.
And there's been quite a bit of research done right here in the province of Alberta. There's been good research done at the university on fire modeling. And so what kind of heat flux do you see as a fire approaches? What kind of heat flux do you get from grass fires? What kind of heat flux do you get off of a tree burning? We looked at all that research and said, okay, let's design a fire test that we can put this system through so that we can see this is how you best predict performance. And because we have a fairly sophisticated fire test furnace, and we subjected a lot of poles to testing and found that they did exceptionally well against grass fires. So we said, okay, well, if we really want to then test its limitations, let's go worst case scenario. What if you had a full-on forest fire that engulfed for a certain period of time a power pole? Could it survive that? So that's the model that we went to with the fire test furnace, subjected power poles to that testing, and found that they would indeed survive that kind of fire. So that's when we knew, okay, this is a good system. Then as a kind of a comparison, we take uncoated poles, we put them in the furnace, we run the same kind of a scenario, but once that pole gets any kind of ignition source without any protection, it starts to smolder. And even though you think there's no more source of heat, there's ventilation that we give it, say, okay, this is what would happen if there's just a little bit of a breeze blowing, or even just available oxygen after a short fire. And an unprotected pole will start to smolder, and over the course of the next 4, 6, 12 hours, it will just completely burn until there's nothing left.
In the final analysis, Safecoat PFP meets all the criterion as an effective solution of fire protection for wood power poles. It's breathable, gaffable, quick and easy to install, and provides a high level of long-term fire protection for the wood pole.
The threat of wildfires remains constant, but through the work at Quantum Chemical, utility companies and the customers they serve can be assured that Safecoat PFP will help keep their lights on at night when fire does strike.